Hi, we continue with our introduction to problem solving with a slight twist to the problem we looked at in the previous video. So here's the statement of the problem. A man in an airport walks at a brisk pace of 5 miles per hour. He then comes upon a moving walkway moving in the opposite direction and at 2 miles per hour relative to the floor. Without breaking pace, he walks onto it. How fast relative to the floor does he move while on the walk? Again, this should be a very simple problem. Obviously the answer is 3 miles per hour. But let's make sure we know how to model these problems so as they become more difficult, we'll still be able to solve it. So this time he's walking at 5 miles per hour, so that's a very brisk pace. Once he gets on the moving walkway, he continues to walk at that pace. So now relative to the walkway, he's moving at 5 miles per hour. So again, we'll use this expression to represent the velocity of the man relative to the walkway. And now the walkway is moving at 2 miles per hour relative to the floor, but in the opposite direction. So here, this is the expression again. Notice we don't make this negative or anything. This is the velocity of this expression represents the velocity of that walkway. And of course, what we want is the velocity of the man relative to the floor. So velocity of the man relative to the walkway, the velocity of the walkway relative to the floor, the velocity of the man relative to the floor. This is what we want to find. So this vector here represents a velocity of 5 miles per hour to the right. This vector represents a velocity of 2 miles per hour to the left. And of course, what we want to find is this velocity. So remember, the velocity of the man relative to the floor is equal to the velocity of the man relative to the walkway plus the velocity of the walkway relative to the floor. So which means then that we have to add these two vectors. So we can add these by putting one like this. And then remember, it's the tail of one to the tip of the other. So we can do it like this. But notice this tends to be a bit obscure. So let's just put it above like this. So again, strictly speaking, the tail should be touching the tip, but in this case it would cover this vector, so we don't want that. So let's just put this like this here, and then this velocity like this. Of course, the sum of these two vectors runs from the tail of the first to the tip of the second. So then that gives us this right here. See how easy? So now if we were going to solve this problem, we would now know that this vector is what we have to find. So that's what you do when you solve a problem. You model it, you bring it to a form that you're familiar with. So later on when you do problems, you will know how to calculate these vectors. In this case, we can just use the facilities offered by GeoGebra. So if this is 0 degrees, that means a magnitude of 5 meters per second in the x direction. That's 3 meters per second at 180 degrees, so that's to the left. So remember, these angles are given counterclockwise from the positive x direction. And of course, we can just see the label here, and that's 2 meters per second to the right. So that's it for this problem. In the next video, we'll look at a slightly more difficult problem, and I want you to remember this principle. The velocity of the man relative to the floor is equal to the velocity of the man relative to the walkway plus the velocity of the walkway relative to the floor. Try and get this intuition into your head. If not from this problem, from the previous one. And then you'll be able to solve any problem involving relative motion. Okay, so that's it for this video.